Hello and welcome to Algebra 2 Lesson 1. In this video, we're going to start learning about sets. So before we kind of get started with the main topics of Algebra 2, I thought it would be very important to cover the topic of sets. And the reason for that is a lot of times this gets skipped over in your Algebra 1 and your Algebra 2 class. And there are things that come up that are related to this on standardized tests such as the SAT and the ACT. Additionally, when you get into college level math, there are things that you're expected to know that are related to sets. So with that being said, let's start out by just giving a basic definition for a set. So a set is just a collection of things, or you could say a collection of just some stuff. Now, it should be clear whether something belongs to the set or not. Now, generally speaking, when we're talking about an algebra class, when we talk about a set, we're talking about a collection of numbers that fit a certain profile, or you could say a collection of numbers that fit a certain definition. So as an example, let's start out by just thinking about the whole numbers. So this is a set or a collection of numbers that fit a certain profile. They start with the number 0, and they increase in increments of 1 indefinitely. So generally, when we list the whole numbers, we'll start with 0. We'll go 0, 1, 2, 3. At some point, we're going to stop because we can't list every whole number. That's impossible. And we'll put 3 dots. Now, when we think about this in regards to being a set, we have some more definitions involved. So the numbers that are listed here are known as the members or elements of the set. And like I said, it should be clear whether something is in the set or not in the set. So as an example, if I asked you, is -5 a member of the set of whole numbers, you would say no, because the whole numbers start with 0 and increase in increments of 1 indefinitely. So that doesn't fit that profile or that definition. So it is clear that -5 is not a member of that set. Now, another thing that we do when we have sets, we enclose our members or elements inside of set braces. So we're going to enclose this inside of set braces. So these are set braces, okay, if you hear that. And the last thing I want to say here is that the method that we're using here is known as the roster method. Okay, this is known as the roster method. And basically what we're doing is we're listing the members or elements of the set inside of set braces. So that's the roster method. As another example, let's say we talked about the set of integers. Okay, the set of integers. So the set of integers, if I use the roster method again, inside of set braces, I would have 3 dots coming this way, comma. I'd start with something like, let's say, -2, then -1, then 0, then 1, then 2, then comma, and then again, I'm going to put 3 dots. And again, in case you don't know what the 3 dots are, they're known as an ellipsis, and they just tell you that the pattern is going to continue. So going this way, I know that I'm decreasing by 1. So after -2, I'd have -3, then -4, then -5, so on and so forth. This way, after 2, I'd increase by 1. So I'd have 3, then 4, then 5, so on and so forth. So this is the set of integers. And again, it's clear whether something's in that set or not. If I gave you the number 0.675, it's clear that that's not an integer. It's not in that set. Now, although generally in algebra we're going to have sets that involve numbers, we can have sets that don't involve numbers. So let's say as an example I had a set that contained the first 5 letters of the alphabet. Well, again, using the roster method, I would list A, B, C, D, and finally E, right? The first 5 letters of the alphabet inside of my set braces. All right, so now that we have the basics under our belt, let's talk about a couple of other things. So the order that we list the elements of a set is not important. So let's say, for example, I have a set whose elements would be 1, 6, and 7. This would be equal to the set whose elements would be, let's say, 6, 7, and 1. And it's also equal to the set whose elements would be 1, 7, and 6, as an example. The order is not important. What's important are the elements or the members of the set. If this set contains 1, 6, and 7, and this set contains 1, 6, and 7, and this set contains 1, 6, and 7, they're equal because the members or elements are the same. As another example of this, let's think about the states that border Louisiana. Okay, my home state is Louisiana, and so the states that border it are Mississippi, Mississippi, okay, kind of hard to spell, then Arkansas, and Texas. So this is the set whose elements are the states that border Louisiana. And this would be equal to the set with the same elements just reordered. So let me reorder this. Let me write Texas first, then write Mississippi, Mississippi, and then let me write Arkansas last. And again, I could change the order as much as I want. What's important here are the elements or the members of the set. All right, so generally speaking, we can use capital letters to name a set. So we want to let A be the set of whole numbers less than 4. So we know the whole numbers start with 0 and increase in increments of 1. So I would put a capital A out here, and this equals inside of set braces. So again, the set of whole numbers less than 4 start with 0, then 1, then 2, then 3. It's less than 4, so I'm not going to continue after that. So this is my set A. Again, that's got the elements 0, 1, 2, and 3 involved. All right, so another big one that you need to know is a set that contains no elements is referred to as an empty set or null set. So once we get into Algebra 2, we're going to start using something known as solution set notation. And a solution set is nothing more than a set whose elements are a solution to your equation. So as an example real quick, let's say you had something like 2x minus 5 is equal to, let's say, 27. So add 5 to each side of the equation. That would cancel. You get 2x is equal to 32. Divide both sides of the equation by 2. You get x is equal to 16. So to write this in solution set notation, I just literally put 16 inside of set braces. That's all it is. This is a solution set. This is a set whose elements are a solution to the particular equation that you're working on. And this isn't particularly that useful when you get into Algebra 2, but if you get into higher levels of math where you solve something and you got a bunch of solutions, it's just a neat and clean way to organize your solution. Okay, that's all it's used for. But we sometimes get equations that can't be solved. Okay, it'll have no solution involved. So a set that contains no elements is referred to as an empty set or null set. So what we're going to do is, if we have an equation with no solution, we're going to use this symbol right here to denote that, because that particular solution set has no elements, right? So if it has no elements, it's the null set or the empty set. So you can use this symbol here for that, or you can also use set braces with nothing inside. But one thing I want to warn you of, and this is a big thing when you get to college math, do not do this. This is wrong. Okay, write that down. It's a very common mistake that students make. Do not put this symbol inside of this. You don't want to do that. That is the set that contains one element, and that element is the empty set. And I don't want to go into set theory and start confusing you, but just know that it's wrong, okay? You can use this symbol or you can use this symbol, but you cannot combine the two. So as another example of this, let's say I said let B be equal to the set of all pigs that are living on Saturn. Now, I've never been to Saturn. Chances are you've never been to Saturn. But I'm going to say that there are no pigs that live on Saturn. So that set would be an empty set, right? That set would contain no elements. So we can say that this set can be denoted by the symbol for the empty or null set. Or you could also say B is equal to this. But again, you cannot say that B is equal to, inside of set braces, placing this symbol in there. That again is wrong. That is wrong. Do not do that. No. All right, so the next thing is that this symbol here, which if I draw it, let me draw it. It looks like a sideways U, and then you just put a line down the center there. So the symbol here is used to denote is a member of the set. So as an example, we have set Z, and Z is equal to, we have the members 3, 7, 1, and 8. So what I can do is I can take each one, and I can say, okay, 3 is an element of set Z. It's denoted like that. Or I could say 7 is an element of set Z. Or I could say 1 is an element of set Z. Or lastly, I could say 8 is an element of set Z. Now similarly, the symbol here, basically we just put a line through the other symbol, is used to denote is not, let me highlight that, is not a member of the set. So with the same set Z, with the members 3, 7, 1, and 8, I could do something like this. I could say something like 6 is not an element of the set Z. I could really use anything I want other than these 4 numbers. I could say 0 is not an element of set Z. I could say negative 32 is not an element of set Z. You know, so on and so forth. So another important concept would be that of the universal set. So this one's a little bit difficult to wrap your head around at first, but something after you practice a few of these that you really can understand. So the universal set, which is generally denoted with a capital letter U, is a set that contains all elements under consideration. Now, if we're talking again about the states that border Louisiana, let's just name this for the purposes of this example here. Let's name this as set A. So set A has the elements that fit this profile where they're states that border Louisiana. So we already know that this would be Mississippi, Mississippi. We know it would be Arkansas. And we know that it would be Texas. Okay, so 3 elements in this set. But if we think about the universal set here, what are all elements under consideration? Well, we're talking about states in the United States of America. So all elements under consideration would be all of the states in the United States of America. So the universal set here would contain every state. Now, we're not going to list all of them. That would be very time consuming, but in alphabetical order, we could just start with 2 of them. So in alphabetical order, it would be Alabama. Then it would be Alaska. And let's put our 3 dots there. And let's finish up with the last 2, which would be Wisconsin and then Wyoming. Now, as another example of the universal set, let's say we're again talking about the United States. So the United States has a president. We all know this. And we could talk about a set, and let's call it set A again, whose elements are the presidents that are currently living. Now, this set would change over time. We're filming this video in 2015. So in 2015, the living presidents, we would have Jimmy Carter. We would have George Bush Sr. So let's just put G period B period. And we'll put number 1 because he was the first George Bush to be president. Of course, his son would be George Bush II. So then comma, after him we have Bill Clinton. And then comma, we're going to have George Bush number 2 or George Bush Jr. So G period, B period, and then 2. And then we're going to have Barack Obama. And to fit this on the screen, I'm just going to put B period, O period. And then we're going to close up with some set braces at the end. So these are all the living presidents as of 2015. Now in 2016, we're going to have a presidential election. So for sure it's not going to be Barack Obama because he's going to be out of office. So we'll have another president to add to this list. But as people pass away, as new presidents get elected, this set would change over time. But what's important is to understand that the universal set, the set with the capital letter U, would be what? It would be all of the U.S. presidents that ever existed. Okay, so we would start with George Washington. So George Washington. And then the next one was John Adams. And then, of course, after that, you had Thomas Jefferson and so on and so forth. So let's just put 3 dots here. And we'll kind of come in with the final 2. We had George Bush number 2, or George Bush Jr. And then we had Barack Obama. And again, it could be whoever in the next election that wins. So this list would be added to. If Donald Trump wins, if Hillary Clinton wins, if somebody else wins, we'll have another president to add to both lists. All right, so additionally, we have finite sets, which have a specific number of elements. And then we have infinite sets, which have an unlimited number of elements. So as an example of a finite set, let's say I told you that we had a set A, which was the whole numbers that were less than 6. So this would be 0, 1, 2, 3, 4, and then 5. So that's a finite set. I can count 1, 2, 3, 4, 5, 6 elements involved there. But if I said, give me the set of whole numbers, or give me the set of numbers that are larger than, let's say, 5. Those are each infinite sets because they go on forever and ever and ever and ever. You can't possibly count them. Okay, so that's an infinite set. All right, so let's wrap up the lesson by talking about subsets. So this is something that you might get tested on. Kind of the other stuff we looked at was just kind of, basic definitions. But these are things that you might have to think about a little bit. So let's take a look at subsets. So if I have set A, which contains the elements 1, 7, and 3, and set B, which contains the elements 1 through 8, then A is known to be a subset of B. And more specifically, A is a proper subset of B because B contains all elements of A and they're not equal to each other. So A is a subset or a proper subset of B. And a lot of times this gets confusing because you have A and you have B, and this kind of looks like a C. So let me make it a little longer. I'll also do it in a different color. Let me do that. So it kind of looks like a C. But that is the symbol for is a proper subset of. Again, if you look at B, it's got 1, it's got 7, and it's got 3. Now, if 2 sets are equal, meaning they have exactly the same elements, they're known as improper subsets of each other. So in this example, we have G, which has 1, 8, and 2, and D, which has 2, 1, and 8. These 2 sets are equal to each other because they have the same elements. 2 and 2, 8 and 8, 1 and 1. So the exact same elements, so they are equal. So we can say they are improper subsets of each other. So we show that by saying G is an improper subset. You see that little bar? Is an improper subset of D. And then also you can say D is an improper subset of G. And let me just label this. This is G is an improper subset of D. All right, so we use the symbol here to denote is not a subset of. So it's just the proper subset symbol with a line drawn through it. So as an example here, we have these 2 sets. We have Q, which has A, M, N, and O. We have L, which has A, D, Z, P, O, and N. So we'd ask the question, is Q a subset of L? Well, no, it isn't. And the reason it's not, this has A and this has A. This has M. This doesn't have M, so no M. This has N, and this has N. And then this has O, and this has O. But because it's missing this M here, it's not a subset. For something to be a subset of another, it's got to contain all of the elements. You can't be missing something. So Q is not a subset of L. Q is not a subset of L. But if I was to change this set, and let's say I was to put an M in there, then it would be a subset, because L would contain all of the elements of Q. So that's what we mean here when we say Q is not a subset of L. So lastly, let's discuss how many subsets can be made from a given set. Well, the answer to that is 2 raised to the nth power, where n is the number of elements that we have. So for example, if I have P is equal to, let's say 5, 7, and 9, well, the number of subsets that can be made from this is 2 raised to the power of 1, 2, 3, or 8. You can prove that to yourself by listing the possible subsets. So one subset would be just the set 5. Then another would be 7. Then another would be 9. Then I would have a subset where I would have 5 and 7. Another would be 5 and 9. And another would be 7 and 9. Then another one would contain all of the elements. And what is the last one? A lot of people don't get this, and it's something you kind of need to be told. Well, the empty set is considered to be a subset of all sets. And why is that the case? That's one thing that many students struggle with. Well, you have to think of subsets as possible choices from the set. So I can choose 5. I have that. I can choose 7. I can choose 9. I can choose 5 and 7. I can choose 5 and 9. I can choose 7 and 9. I can choose 5, 7, and 9. Or I can choose nothing. I can choose nothing. So as an example we can kind of understand, let's say that I have a set L. So I have a set L, and L contains 3 elements. It's the elements that are in my lunchbox that I'm bringing to work. So let's say I have chips, I have soda, and I have a sandwich. Make it real simple. So what are the possible subsets that I can make here? We know there's 3 elements, so that we know there's going to be 8 using our formula. But let's go ahead and list them. Again, think about possible choices. What can I take out of the lunchbox? Well, I could take out just chips. I could take out just a soda. I could take out just a sandwich. Now, I could take out 2 items if I wanted to. I could take out chips and soda. I could take out chips and a sandwich. I could take out a soda and a sandwich. And then I could take out all 3 if I wanted to. I could take out the chips, the soda, and the sandwich. And then lastly, I could choose to just take out nothing, right? I could choose to open my lunchbox up and say, you know what, I don't want anything. So my choice is to choose nothing. So that becomes the empty set choice. And so I have my subsets. I have 1, 2, 3, 4, 5, 6, 7, 8. And that is given to me by my formula, which is 2 raised to the number of elements I have. I'm going to have 1, 2, 3 elements. 2 to the 3rd power is 8, and I've listed them there for you.